our experiment, we reacted 3 metals, iron, zinc, and magnesium, with hydrochloric acid to show how heat is released when a metal reacts with a strong acid. The principle that we are testing in this experiment is that when a strong acid reacts with metal, the reaction is exothermic, forming a salt and an H2 gas. The enthalpies of the reaction rely on the second ionization energies of the metals, since each metal loses 2 electrons.
The lowest of the ionization energies is magnesium, and then zinc is a bit higher, and then iron is higher than that. Therefore, the most reactive will be magnesium, and the least reactive will be iron, and then zinc will be in the middle. Okay, ready?
Yeah.
No!
All that wasted time.
Dave Hunt, this is gonna be one. Come on. This is gonna be the one.
Let it be.
It just dropped. So for our first reaction, we used coarse steel wool as the control. We measured it out earlier in the video, and now we're going to add 200 milliliters of hydrochloric acid to the beaker with the coarse steel wool. The hydrochloric acid is 12 molar. So as we pour in the hydrochloric acid, this reaction is pretty slow, so you won't see it right away, but the solution will start to change color from clear to this cloudy white, and as the reaction proceeds, you can see a little bit of hydrogen gas coming off the top of the beaker. We put the thermometer in to measure the temperature. We speed up the video and there is the hydrogen gas escaping. So for the reaction with the coarse steel wool, the solution had an increase in temperature of around 7 degrees Celsius. Our next reaction was the fine steel wool, and into the beaker we poured 100 milliliters of 12 molar hydrochloric acid. We put the thermometer in once again to measure the temperature. Once the reaction starts, you'll be able to see the hydrogen gas coming off the top of the beaker, in addition to the solution changing color to a murky white. For this reaction, the temperature increase was around 4 degrees Celsius, which was less than the control because in this one we had less steel wool and less hydrochloric acid, thus making the whole thing less reactive. For the next experiment, we used mossy zinc, which are small nuggets of zinc that were created by rapidly cooling molten zinc. You'll notice as we pour in 100 milliliters of 12 molar hydrochloric acid, the reaction proceeds very quickly, emphasizing its reactivity. A lot of hydrogen gas comes off the top and the clear liquid turns murky and bubbly. We put the thermometer in and the temperature increase at the end of this reaction was around 30 degrees Celsius. It is higher than iron because zinc has lesser ionization energy than iron, which makes it more reactive. So for the last reaction, we used magnesium turnings, which we cut up into little pieces to increase the surface area and therefore the reactivity. This reaction starts super fast, and as you can see there's a ton of hydrogen gas coming off the top from the 100 milliliters of 12 molar hydrochloric acid. The temperature increase was 50 degrees Celsius, much higher than the iron and the zinc because magnesium's ionization energy is much lower, and therefore magnesium is very reactive. After conducting the experiment, we found that the temperature change of the reactions was highest for magnesium, second highest for zinc, and lowest for iron. This trend of increasing temperature change reflects the trend of the values of the enthalpy of the reactions, with magnesium having the highest magnitude, followed by zinc and then iron.
Mr. Stevens in the house. Are you recording right now? Hey. Oh yeah.